Hi everyone, it's me again. So last time we talked about the 7 butterfly families: Papilionidae, Hydaellidae, Hesperiidae, Pieridae, Nymphalidae, Lycaenidae, and Rhyodinidae. If you have no idea what I'm talking about, I've left a link to the last video in the description box below. The rest of you have undoubtedly already become expert butterfly identifiers. Now all you have to do is glance askance at one fluttering from afar and you've got it pinned, at least to the family level. But what if someday you encounter a butterfly that you can't quite place? What do you do when that gestalt doesn't feel familiar? Fear not. Today we will learn a more scientific method of butterfly identification, and then we'll use it to ID some of the most common butterfly species. So try to stick it out until the end of the video. I promise you will feel super smart. Alright, let's get into it. The secret is wings. A lot of the time, even if insects from different orders look really similar, their wings will look really different. This is also true for butterflies and moths. Even if the color and pattern of scales looks similar, the underlying structure of the wing is often different. And in fact, this turns out to be a very useful way of identifying butterfly families. So a long time ago, someone came up with a way of describing these differences, a kind of language that we can use to discuss insect wing venation. And it goes something like this. So here we have an insect wing. The costa runs along the top, and under that is the subcosta. You still with me? Alright. Then you have the radius, which can split into up to 5 branches. We call these R1, R2, R3, etc. The vein in the middle of the wing is called the media, and it can split into up to 4 branches. Under the media comes the cubitus, which splits into up to 3 branches, and at the base of the wing are the anal veins. These ones never branch, and you can use that to your advantage, because if you count up from the bottom, you know that the first big branching vein is the cubitus. Then comes the media, then finally the radius, which often gets squeezed alongside the subcosta. Finally, these things are called cross veins, because they cross veins. Now, this is the wing of a generic insect. Here are the wings of a generic butterfly. The dotted veins are optional. No, wait, bring them back. They help you see the radius, media, and cubitus. Do you see them? Okay, you can go. This big blank area, by the way, is called the discal cell. Now, all butterflies have 2 branches to their cubitus, which go along the bottom of the discal cell, and 3 branches to their media, here. 2 branches, then 3 branches. That's important, so remember it. So, how do these veins vary among the butterfly families? Let's go in order. Here are the wings of a generic swallowtail. The tail should be your first clue that it's a swallowtail, but it's not always 100% reliable, you know? So you can also look for a second anal vein, A2, which goes right up to the wing edge. Most other butterfly families only have 1. And on top of that, swallowtails also get a cool cross vein here. No other butterflies have one of those. The wings of Parnassians are quite similar, except that they don't get that cool cross vein, and their A2 can sometimes be a little hard to see, because it goes right along the edge of their wing, underneath their armpit hair. Hydaellids haven't lost the veins inside their discal cell, so their wings have a kind of stripy look. And also, they look like moths. So, yeah. Alright, if you remember, about 1 minute ago I said that most butterfly families only have 1 anal vein. Well, skippers also have 2, they're the only exception, but their A2 does not reach the edge of their wing. Instead, it does a little loop-de-loop, or just stops. If A2 is buried under immense amounts of body hair, you can also look for a really long discal cell, which adds to their neat, angular shape. Here is a generic pierid. Aren't they all, though? You can see that it only has 1 anal vein, so good news, I wasn't lying. Now, these are the only butterflies with this particular vein arrangement, with one of the veins from over here reaching up to the main vein. In scientific terms, we say that M1 is stalked with R beyond the discal cell. I like to call this the motorboat formation. Here are the wings of a generic nymphalid. As you know, this is a big butterfly family containing all kinds, which makes it difficult to generalize. The best way to identify nymphalids is by counting their legs. But their wings do have a few characteristic things. Their radius has tons of branches, by which I mean 5, but M1 never reaches up in there, and they only have one anal vein, of course. Lycaenid wings are a lot simpler and more consistent. Their radius only has 3, sometimes 4 branches, with just one of these Y-shaped splits, maximum. Probably because these butterflies are a lot smaller. There's not as much room for goofing around. Rhyodinid wings are basically the same as lycaenid wings, maybe a little bit pointier near the ends. You know, people used to think that rhyodinids were lycaenids, namely that Rhyodininae was a subfamily of Lycaenidae, and some people still want to shove them back in there. So it's possible to tell these two apart, just not by wing venation. One thing is that rhyodinids usually perch with their wings out, while lycaenids perch with their wings up, usually. Also, rhyodinids are mostly only found in Central and South America, where they have a crazy variety of patterns and colors. Meanwhile, lycaenids are found almost everywhere, but tend to just look like lycaenids. And finally, just so you know, some rhyodinid males also have reduced forelegs. I know, that's terribly confusing. I'm sorry, they didn't ask me, you know. Alright, what have we learned? If you're outside and you see a butterfly, first you should ask yourself, can you see 4 or 6 legs? 4. All right. How many branches are there in the radius? First, let's remind ourselves where the radius is. From the bottom, we have the cubitus, then the media. So the radius is all squeezed together at the top. And it has 1, 2, 3, 4, 5 branches. So that looks to me like an nymphalid. Let's go again. Does it have 4 or 6 legs? 4. Okay. How many branches are there in the radius? 1, 2, 1, 2, 3. 1, 2, 3. Less than 5? That's a rhyodinid. Here is a butterfly eating a banana. 4 or 6 legs? 4. How many branches in the radius? Let's take a closer look at those wings. Wow. So there's the cubitus, the media. The radius is there, but it's kind of hard to count. Sometimes it helps to flip it back over. Okay, there we go. Now I see it. 1, 2, 3, 4, 5. That's a nymphalid. Now here's another cool butterfly. 4 or 6 legs? 6. Okay. Now ask yourself, does M1 reach up to touch R? 1, 2, 1, 2, 3. Yeah, there's that shape. That means that this is a pierid. Easy. Give me another one. Wow, okay. 4 or 6 legs? 6. Does M1 touch R? 1, 2, 1, 2, 3. No, it does not. Now, does it have 1 or 2 anal veins? Well, that's A2 right there. Is A2 curved or straight? Straight. So this is a papilionid. All right, last one. 4 or 6 legs? 6. Does M1 touch R? Nope. 1 or 2 anal veins. Let's see. I only see 1. How about you? So now, according to our system, this is either a lycaenid or rhyodinid. It has metallic spots, like a rhyodinid, but perches with its wings closed, like a lycaenid. It also has rounded wings, lined with white fringe, like a lot of lycaenids do. And okay, I happen to already know that this is a lycaenid. It just has that look about it, don't you think? By the way, what we just did, obviously it was super fun, but you may not know that it was also super scientific. We used what is called a dichotomous key to, as they say, key out butterfly families. Here is the key in its entirety. It's just a list of if this, then that type questions, which, if you go through them one by one, will lead you to the correct butterfly family, most of the time. How cool is that? I'll leave you with a few more beautiful butterfly pictures. How about you try to key them out yourself? And leave your guesses in the comments below. All right, that's it for now, everybody. Thanks for sticking with me, guys. See you next time.